All right, welcome everyone. So in this video, we'll take a look at one last property, which is how is the determinant of an invertible matrix A related to the determinant of the inverse of matrix A. And in order to prove this result, we're going to use the result of the previous theorem that we just proved, which was namely if we are taking the determinant of a product of two matrices, two square matrices A and B, that we could write this as the product of their determinants. So from that result, we're going to show the following, that if A is an n by n invertible matrix and A inverse is the inverse matrix A, then the determinant of the inverse of matrix A is equal to 1 over the determinant of A. So we take the reciprocal of the determinant of matrix A. So let's see why this is true. Let's start by supposing we have some n by n invertible matrix A, and its inverse we denote A inverse as usual. And so this means, by definition, that when I take the product of A with its inverse on the right, we should get the n by n identity matrix. So this tells us then that the determinant of A times A inverse, since A times A inverse is the identity matrix, that's going to equal 1, since the determinant of the identity matrix is 1. The identity matrix, recall, is the matrix that has 1s along the diagonal and 0 everywhere else. So the determinant of this we would get by taking the product of all of the 1s on the diagonal. And that's why we get a 1 over here. So now we can use this result about the product, the determinant of the product of matrices. So now I know that the determinant of A times A inverse is 1. And now I know that I can break up this product as follows. The determinant of A times A inverse is equal to the determinant of A times the determinant of A inverse. And from this, we see, therefore, if I take both sides and divide by determinant of A, and I'm allowed to divide both sides by the determinant of A because I know this is not 0, right? If A is invertible, its determinant is not equal to 0. So I divide both sides by the determinant of A, and that allows me to solve for what the determinant of the inverse of matrix A is. Namely, it's 1 over the determinant of matrix A. So there's a nice useful property about matrices and their inverses and what relation their determinants would satisfy.